Hello, good afternoon, everyone. Okay, good to see you again. I hope that you're having a good Saturday, right? I know that some of you are having your exams. The Form 4 are going to have your exams soon. The Form 5s are in the midst of your exams, okay? So I hope that today's lesson will help you in any way possible. It will help you to understand and also possibly, okay, help you to understand, to answer some questions. Okay, so today, who do I have with me? I think I see Kenneth here. Hello, Kenneth. Okay, thanks for watching, and I hope you can share the link to your friends later. All right. Okay, so let me start by sharing my screen. So today's class is actually very simple. You have learned some of it in Form 3 before. That was 2 years ago when you learned about blood groups, blood groups of humans. All right. So we are just like revising a little bit. Okay. So and also a bit more we have to add on. Okay, we have to add on this rhesus factor. Rhesus factor is the determination of the type of blood based on another type of antigen. That means that's why you have your O positive, O negative, A positive, A negative, and so on. Okay, so I'm going to start now. Right, this is blood groups of humans. So as you know, there are actually 4 types of blood grouping. Okay, you have learned in Form 3 before. So you have your A and your B, AB and O. All right, 4 groups. So now why are there 4 groups? Why not more? Okay, and why do we call them A and B, AB and O? So there must be a reason to it. Why we label it as A and B, right? Not other names. Okay, so the human blood group is classified into the 4 types. All right, A, B, and O. Right. Now, how do we classify? Why do we call it A? Why do we call it B? And then we also need to know why is it important that we cannot just simply donate anybody's blood to any person, okay, without first checking the type of blood. Because there is a kind of what we call a reaction. If you give certain blood to another person whose blood is not compatible with this person, there is going to be complications that arise later that can be fatal, that can cause a person to die. Okay, so now donation and transfusion. Donation means is to give blood, one person giving blood to another person. Transfusion means transferring blood. Okay, transfusion is just like pinda darah, transferring blood. It's based on compatibility. So you see the keyword here. Compatibility means the suitability of the blood group of the donor and the recipient. The donor is the person who gives the blood. The recipient is the person who takes the blood. So these 2 people, the blood grouping have to be compatible. Okay, that means this blood must be able to be received by the other person. Okay. The recipient has antibodies in the blood. So why does it need to be compatible? Because the recipient can produce certain antibodies that can bind, or we can say can act against the antigen. If you give the wrong type of blood to this person, if this person has the ability to produce the antibody for this blood, this antibody will bind onto the antigen of this blood, and it can cause the blood cells to stick together. And when it stick together, that means your blood cannot flow and the person will die. Okay, now, so we're going to look at the entire lesson, half of the lesson. We're going to look at this case, why what kind of reaction is this, okay, and the compatibility of what group and what group. Okay, so let's look at why do we call it as A blood group first. All right, so you see on the surface of the red blood cell, okay, you can't see, actually it's too small. There's a kind of protein, that exists on the surface. Okay, we call it antigen. Now this is just a representation. When I draw all this blue color stuff there, all right, this shows the antigen. All right, so let's say antigen A, but it's not as big as this. Okay, it cannot be seen. Even under the microscope, you can't see it. This is just a representation. to show you that there's a kind of protein on the surface. Okay, so if this person has this type of antigen A on all of his red blood cells, this person is known to have A blood group, okay, or blood group A. And then in humans, scientists has also found out there's another type of protein that is found on the surface of the red blood cell, okay, which is different from antigen A. There's another type of antigen, so they just call it antigen B. Right? Let's look at this. So let's say I represent it with a triangle. That triangle is a bit sharp. Just now the antigen A, the triangle is a bit blunt at the top. All right, and then we call this, let's say, antigen B, because it's a different type, so give it a different name, right? So this person who has antigen B on the surface of the red blood cell is known to have B blood group. Okay, blood group B. Now then, scientists have also found there are some people who happen to have these two types of antigen on their surface, the surface of red blood cell. That means on the surface of red blood cell, they have these two types together, antigen A and also antigen B. Okay, so these people, you can see here very clearly, antigen A and antigen B exist on the red blood cell. These people, these type of people, right, we call them blood group AB. Blood group AB. Okay, there is no antigen called AB, yeah? So be careful when you write. You cannot say antigen AB. There's no such thing as antigen AB. There is only antigen A and antigen B. You have to write it separately. Don't be lazy. You cannot say antigen AB. That is wrong. Okay. Then scientists have also found that there is another group of people who do not have any antigen, like neither A or B. Okay, don't have antigen A, don't have antigen B on the surface of the red blood cell. And these people are known as, I'm sure you have guessed it, right? So these are blood group O, right? No antigen. Okay, so that's how you classify the type of blood grouping. Depends on the type of antigen on the surface of the red blood cell of the person. And you can't see it actually, it's just a representation. This diagram shows a representation. Okay, now you also see something there in the blood there. There's a plasma, right? Okay, now looking at this antigen A, now you will see that this other diagram that I'm showing, this thing here is an antibody. So if that person has antigen A, that person should not come into contact with antibody A. Antibody A is the type of protein that will be able to bind onto the antigen. So this should not happen. All right, that means a person who has antigen A should not have antibody A, because if that happens, the antibody A exists in the blood of the antigen, the person with antigen A. This antibody will stick onto or bind onto the antigen A, cause the blood cells to stick together, and they cannot flow. And the person will, of course, will be deprived of oxygen, and the person will die. All right, okay. So similarly, you see your antigen B, right? Antigen B is the one with the orange triangle. So it cannot have the antibody for B. You see the shape matches. This is antibody B, right? So this person who has antigen B must not have antibody B. In other words, they should not meet. Okay, antigen cannot meet the antibody. If that happens, again, the same thing, it will bind together and it will cause sticking, the clumping of the blood. Okay, so you will see in the blood group A. Blood group A, it does not have antibody A, but it can have antibody B. You can see here, the green color, that wedge there, right? That kind of, the triangle being cut out there, that is representing anti-B antibody. It cannot have antibody, anti-A, but it can produce anti-B. All right, and then next, for your blood group B, it cannot have anti-B antibody, but it has the ability to produce anti-A antibody. Okay, so when an antigen comes in, all right, it will be able to produce an antibody. Okay, now what about AB? Okay, what about AB blood? Where it has antigen A, it has antigen B, so therefore it cannot have any antibodies. It cannot have the antibody A or the antibody B. Okay, and for blood group O, because it does not have any antigen, therefore the plasma, right, this plasma of the blood group O, it can have anti-B antibody and also anti-A antibody. Okay, so basically you need to remember that your antigen cannot meet with the antibody. Okay, A antigen cannot meet with antibody A. Antigen B cannot meet with the antibody B, but it can have the other antigen, or it can have the other antibody. All right, okay, clear with this? All right, okay. So now let's see blood transfusion. Blood transfusion is called pindah darah. That means you transfer one person's blood into another person. Okay, now if the blood group of both the donor and the receiver is not compatible means not suitable, right? The red blood cells of the recipient, the person who received the blood, right, the blood cells will experience agglutination. Okay, use the correct term. It's either agglutination, better to use agglutination, okay, than coagulation. The meaning is roughly the same. That means they stick together. Okay, they stick together, causing the red blood cells not to be able to flow. Okay, so let's look at this in diagram form. Easier for you to understand. Okay, let's say this is blood B. Okay, the donor, the person who's going to donate the blood has blood B. So if the person has blood B, that means he has antigen B on the surface of the blood cell, right? So let's say he is going to donate this B blood to another person, and that person happens to be an A. Let's say hypothetically, okay? Let's say the person is A. Can the A receive blood B or not? Blood B or not? Okay, now so look at what type of antigen does it have. It has antigen B. So if the antigen B enters the blood of the recipient, the A blood, the A blood, remember we said that it can produce antibody B. All right, it doesn't produce antibody A, but it can produce antibody B. So now if that antigen B comes into this person's blood, the antibody B will be there. So it's going to bind onto the antigen, and that causes these red blood cells to all stick together, and you have something what we call agglutination. Okay, so the antibody will bind to the antigen. So therefore you see B blood type cannot be donated to A blood type people, right? Donor of B, the B blood cannot be a donor to A blood. All right, okay. So let's go on to the next slide. All right, I think you can understand this. So this is what you've already learned also in Form 3. This is just a revision. All right, now, so in order to keep it, make it short and simple, all right, if you forget who can donate to what kind of blood, I give you a very simple way to remember, all right. First of all, you draw a grid, all right, something like a Punnett square, right? Draw a grid here where you have 25 boxes. Okay, the top row, the left row here represents donor. Donor is the person who donates the blood, and the top row is the recipient. Recipient is the person who receives the blood. Now, look at carefully. Definitely, it makes a lot of sense. A person who has that blood group can always receive back the same blood. Isn't it, right? If I'm A, definitely I can receive A. So what you can do is you tick all the diagrams or all the boxes that correspond. So A definitely can take A blood. B definitely can take B. AB will take back AB. O can take O. All right, okay, that is logical. And let's start to fill up the other boxes. Okay, next one. Now, first of all, another line you can take is this one, O. Now, why O can be donated to everybody? Okay, the reason is because O does not have antigen on the surface. So there's no antigen A, there's no antigen B. If this blood enters anybody's blood, there is not going to be any reaction, because even though if the person has got antibody, it doesn't bind to the antigen because O doesn't have any antigen. All right, so O can be given to everybody. The reason is because blood group O, does not have antigen A, neither does it have antigen B. Okay, so it's important for you to recognize it's actually the antigen that you see the reaction, not the antibody. You see what comes in. You must see what this blood has. If this blood has the antigen, look at the receiver. Can it produce the antibody? If it can, then it's going to be the agglutination will happen. Okay, so this is done. Another one you can fill in the tick also is looking at your AB as a recipient. Now, as a recipient, the AB blood, right, will not have any antibody. Okay, will not have antibody. So whoever's blood that comes in, whether it's antigen A or antigen B that comes in, this AB blood will not be producing any antibody. So there's not going to be any agglutination. So therefore, your AB is able to accept everybody's blood. Okay, so A can give to AB, B can give to AB because AB does not produce antibody, antigen A nor antigen B. Antibody A nor antibody B. Okay, so this one you already fill up first diagonally, and then horizontally, and then vertically, and then the rest you can put crosses. So you fill up all the ticks. The rest definitely no need to think, it's all crosses. So you will see now there's one row, the O here, is able to be given to everybody. So we call this universal donor. O is a universal donor. The blood can be given to everybody, and the reason is because O blood does not have any antigen on the surface of the red blood cell. It is not going to trigger any response in the recipient. Okay, and then there is one more row here. You can see your AB. You look at this universal donor. The next one is this one. AB can receive everybody's blood. Okay, AB can receive everybody's blood. The reason is because AB doesn't have the ability to produce antibody A or antibody B. So whoever's blood comes in with that, whether it's antigen with antigen A or with antigen B, or even without antigen, there is no antibody there. All right, so that's not going to have any reaction. All right, okay, so easy to remember. Okay, instead of cracking your head, whether B can give to O, O can give to B can give to AB, whatever. Okay, just draw a grid, put in all the ticks that you already know that makes logical sense. The rest all will be crosses. Okay, simple. Next one, right? Now, so to summarize it. So antigen A blood group will have antigen A. All right, and the type of antibody in the blood serum or in the blood plasma, it can produce anti-B. Okay, it cannot have anti-A. They cannot exist together. All right, then the blood group B will have antigen B, and it can produce anti-A. Blood group AB, it has antigen A and antigen B. Now, do not write antigen AB. There is no such thing called antigen AB. Okay, and it cannot produce any antibody. There's no antibody and A nor antibody B. And for O, no antigen, but it can produce anti-A and anti-B. Okay, so the compatibility, O can be given to A can be given to A and AB only. And A can receive from O and A, or A and O, all right? B can only give to B and AB, and it can receive from B and O. Okay, AB can only give to AB. Okay, AB can only receive their own blood, but they can receive everybody's blood. Okay, AB, and O can be given to AB. Okay, and for O can donate to everybody, but they can only receive their own blood. All right, okay, clear? So this one makes a lot of sense. If you already know, just now you draw the grid box there early on. Okay, now next, let's go on to another factor. This one you didn't learn in Form 3. Okay, didn't learn Form 3 because it's a bit more complicated, but nevertheless, it has the same principle. Right, Rhesus factor. Okay, Rhesus is actually another type of antigen. Okay, we call it antigen D, D for donkey. So let's say now, besides looking at whether it's antigen A or antigen B, or maybe don't have the antigen A or B, There's another type of antigen which we call antigen D, D for donkey, right, on the surface. So if that person has this antigen D, besides the A and the B, whatever, I don't care. We're not looking at the A, B, O. We're looking at whether you have the antigen D or not. If you have the antigen D, you are considered Rhesus-positive. Okay, and then if you do not have the antigen D, you are considered as Rhesus-negative. Okay, so antigen D is another antigen found on the surface. Okay, the person who has antigen D is called Rhesus-positive, and the person who does not have the antigen D is known as Rh-negative, or we call it Rh factor is also known as antigen D. Okay, clear? So you have is positive, you don't have it, you're considered as negative. Okay, next. Now, what about giving blood, donating blood? If the blood of an Rh positive donor, okay, you are a donor is positive, and is given to somebody, the blood enters the blood of a Rhesus-negative patient, a recipient, what will happen? Okay, now because of antigen, the antigen is always able to trigger the production of antibody. So when the antigen enters a person, okay, who doesn't have this antigen, it will have the ability to produce antibody. So it can produce anti-D antibody. So this person will react. If this comes in, if you positive give to a negative patient, this negative patient, the negative Rh patient, will be producing the anti-D antibody. That means you cannot give positive blood to a negative patient. Okay, what happens is this is your antibody, and it will bind. Again, the same thing will happen. It will bind onto the antigen D, and you will have agglutination. So that person will die, right, eventually, if this is done. Right, so positive can only give to positive. Negative can give to everybody. Okay, negative can give to negative. Negative can also give to positive. Simply because there is no antigen D on the negative, on the cell of this red blood cell. Okay, so the negative is the safest, all right? You can give to everybody. You don't need to know if you're not sure whether it's positive or negative, just give the negative. It will not trigger any antigen antibody response. Okay, clear. Now, next one. Okay, so that this case situation just now earlier, positive give to negative, can result in the death of the recipient. All right, okay, next. So now let's go to an important part of this Rhesus factor, the discussion about pregnancy. Okay, there will be a complication. There will be complication that arises if the mother and the fetus, the baby, does not have the same Rhesus factor. Especially, okay, actually not if the baby is negative, the mother is positive, it's not so much of a problem. But now the problem arises if the baby is positive, the mother is negative. The baby can be positive is because the father can be positive. Okay, so problems will arise when a Rh negative mother marries an Rh positive father, and the baby happens to be Rh positive, conceives a Rh positive fetus. Okay, so father is positive, mother is negative, because Rh this allele, you learn it in Form 5 later, this is a dominant allele. So it can appear in the baby, and if the baby receives a Rh positive allele, he or she can be a positive Rhesus. Okay, so this baby, let's say Rh positive, but the mother is negative. All right, now see what's the problem, and later we see how to overcome it. Why the problem exists first. Okay, first of all, okay, now see this baby, quite few term already, the Rh positive blood, and this is a mother who's Rh negative. Now, during pregnancy, okay, in fact, this is the first pregnancy, we're talking about the first baby, right? First baby lah. The fetal blood, in fact, in every pregnancy also, the fetal blood cells, the baby's blood cells, they do not mix with the maternal blood, with the mother's blood, due to the presence of a blood barrier. Actually, the baby's blood, it does not actually come into direct contact with the mother's blood. Okay, because in the placenta tissue, the placenta is that big piece of tissue that sticks the baby to the uterus wall. And there is where the exchange of gases, oxygen goes into the baby side, right, and passes to the baby. At the same time, this blood from the baby that contains high contents of carbon dioxide will diffuse over and pass it to the mother. There is this something called a blood barrier. There's a membrane. Okay, the membrane is usually the capillary wall, okay, of the blood vessel. Now look at this. We have this something called chorionic villi. Okay, this one you will learn later at chapter 15 when you talk about reproduction, pregnancy, and all that, right? So at the placenta there, let me besarkan, magnify this. You will see that maternal blood. This is the maternal blood, the mother's blood supply. Okay, it pours into this space here. You see this space here? Yeah, this space here. This space here. All right. This one, and this is baby's blood. This side, this is called the fetal blood. The fetal blood is in its own blood vessel. There is no break in the blood vessel. The baby's blood does not come into direct contact to the maternal blood because of, you see this line here? This is called the blood barrier. There's something separating the blood. Only the gases passes through, and only the waste material passes through. The red blood cell do not mix with the red blood cell of the mother and so on. Okay, only the substances pass through the membrane. The blood do not mix. And that is important because if it doesn't mix, that means the antigen that is on the surface of the red blood cell will not be able to pass through lah. Okay, which is good lah because it separates them lah. So during the entire pregnancy for the first baby, there is no problem actually. Okay, there's no problem. The blood does not pass through. The antigen positive on the baby's blood does not find its way into the mother's blood. So it cannot trigger the antibody response. Okay, no problem. All right, okay, clear? So there's we call it the blue, the line here is called this blood barrier. So there's no mixing of the blood. All right, now, so, however, during delivery, you see when the mother is about to give birth, right? The mother is about to give birth, there's a lot of contraction. Contraction is the muscle, the uterus wall is contracting, it's going to push, it's going to contract and push, and it's going to try to push the baby out. During that time, all right, the placenta tissue there's going to be tearing, all right? The placenta is going to actually detach itself. So there's going to be blood vessels broken. Blood vessels will break, right? So fragments of the fetal blood cell. So now the baby's blood has got positive antigen on the surface. It can, because of broken blood vessels are broken, the membrane also can be broken. So this positive, this one, right, can cross over into the maternal blood, can cross the placenta during the contractions, during the delivery, all right, and it enter the blood of the mother. So when this happens, the positive, this is the red blood cell with the positive antigen, it enters the blood of the mother, it will trigger means stimulate the mother's blood to produce antibody for this Rhesus-positive. Okay, and the moment she doesn't have, but because nothing triggering it, but because now the blood is able to pass through, okay, when it enters the blood of the mother blood will be triggered to produce this antibody for the positive Rhesus. All right, now, so now, but still no problem. You know why? Because now supposedly this is the antigen. And this is the antibody that's produced. It is supposed to move into the blood right? Move into the fetus, and maybe it will coagulate the baby's blood and so on. It will sort of bind to the antigen, the red blood cell of the baby. But however, that it doesn't happen, right? Okay, so wait, let me just go through this point first. As a result, the white blood cell in the mother's blood will produce anti-D antibodies that will flow through the placenta into the fetal blood circulatory system. So this is what can happen. The square here represents the antibody that the mother produced because triggered by the red blood cell of the baby, because there was a break there. Okay, all right. Okay, now, okay, the antibodies were supposed to destroy the red blood cell of the positive Rh positive baby, right? Because it went in. But however, it doesn't really happen because two reasons. Number one, the concentration of antibody produced is not enough to affect the first child because it's just started. It takes time for the body to produce antibody. So the antigen just came in, so it's going to take time to produce the antibody. All right. And furthermore, number 2, when the contractions happen, the delivery is not far away. All right, maybe a few minutes later, the baby is going to be delivered. Once it's delivered, the placenta will be taken out, the umbilical cord is cut, right? There's no way this antibody that is going to be produced later will find its way back into the baby because the baby has been taken out. Okay, though the baby is not harmed in any way, even though the mother is now making the antibody because the baby has been delivered. What the baby did was just to trigger the mother to produce the antibody, but it didn't come in. It did not affect the baby. So the first child is safe. Okay, the first child didn't die, no complications. The first child is okay. All right, you get that clear, right? Because the baby is delivered, how can the blood come back to the baby, right? Because you cut everything, you take out the baby and she is born or he is born. All right, now, first baby, no problem. But what happened was, now the mother already making the antibody for the Rhesus-positive. The mother is already actively, the red blood cell or white blood cell is being stimulated to make the antibody. So now, okay, it will have the antibody in the mother's blood now. It will have, there will be, all right. So now the baby is being born, maybe next year, 2 years later, she gets pregnant again. Now, let's look at the second pregnancy. Now, during the second pregnancy, there can be a problem. Okay, the reason is, now let's say if the second baby is also Rhesus-positive, all right, because the father is positive, right? So now the baby also happens to be Rhesus-positive, then there can be a complication because now the antibody that the mother is already making, it will cross placenta. Antibodies are small enough, they can cross the blood barrier. The red blood cell cannot cross the blood barrier, but the antibodies that are produced by the mother can now cross the placenta. So now the baby is being formed. Now the antibody will straight away enter the blood cell, enter the circulatory system of the fetus. It goes into the placenta and it can destroy the red blood cells of the fetus. So the red blood cells of the fetus will be destroyed. Okay, and then we call this phenomenon as erythroblastosis fetalis. Erythro means the erythrocyte, the red blood cell. Blastosis means they will rupture, right? They will break. And fetalis referring to the fetus. So you have this problem, all right? But luckily, our technology, our medical technology is so advanced. We can counter this problem. We can stop this problem from happening. Okay? Now, how do we do that? So, right. So the second fetus may die if the blood is not replaced. Either you do a replacement of the blood, all right, of the negative of this fetus through blood transfusion. You change the blood, okay? You change the blood of the positive, the baby, with the negative. I don't know how it's done now. It sounds very complicated. But another thing it can be done is, what you can do is you give the mother an injection, okay? Now, so the problem that can arise is the baby can suffer from anemia because a lot of the red blood cells are ruptured, okay? If it's less serious situation, just baby may be anemia lah. If very serious, the baby will die, okay? Now, this problem can now be addressed, can be overcome by treating the affected mother with anti-rhesus globulin. So we inject the mother after the first pregnancy. We know that she already have this problem. The mother is now producing the antibody for this positive. So we inject the mother with this globulin, anti-rhesus, to stop the formation of anti-D antibody. Okay, to coat this we call it the antigen, so that it does not trigger the Rhesus-positive globulin, that means the antigen antibody to be produced. So it does not produce the antibody. So the second baby will not have this complication. All right, so we inject the mother with anti-rhesus globulins to stop the formation of anti-D antibodies. Okay, so this is how we counter this problem. Right, this is the complication that can arise from rhesus factor in the pregnancy. Okay, so we're done with 10.5. Now we go to 10.6. Health issues related to the human circulatory system. Okay, this is something very general, but it will come out as part of the question together, usually with diet, nutrition. When they talk about the diet, they give you a menu, usually in the essay form. They talk about this, whether this diet is healthy for this person, and then discuss the health issues that may arise if this person takes this food for many months or so on, for long term. For example, eating burger and so on. So you got to talk about all these cholesterol problem, okay? High cholesterol, and how is it going to affect your your circulatory system, your heart, and so on. Okay, it's related, right? So the necessity for a healthy circulatory system, okay? What can you do, all right, to have a healthy circulatory system? Okay, number one, why do you need to have a healthy circulatory system? Number one is to ensure optimal health lah. Okay, nobody wants to die early, right? Everybody wants to live as long as they can, to enjoy life, right? To see their children grow up and to see the grandchildren and so on. Okay, there's nobody's wish to die early. Okay, if there is, there's something wrong, mentally wrong with the person. All right. So practices. What are the things that you should do, right, in order to look after your heart so that you do not have problems with your circulatory system? Okay, these are some of the things you can do. You have to take a balanced intake of food. That means your food have to have certain kind of quality. For example, low fat and low salt. Okay, because salt, the content of salt can increase what we call this high blood pressure. Okay, sodium can increase the blood pressure of the blood. Okay, so low fat, low salt. Exercise regularly because it will burn your fat, so your cholesterol will be not so much cholesterol plugging your, blocking the flow of your arteries and of your blood flow and so on. Exercise regularly to burn off the necessary fat, all right, that you are accumulating inside your body, and tone up your muscles. Do not smoke. What has smoking got to do with it? Somebody must be thinking. Smoking is made for the lung. Why smoking has to do with the heart one, right? So actually it is. Smoking actually has been known to harden, to make your arteries become hard. Harden the arteries. Okay, so it becomes less elastic. So when it becomes less elastic, it's not able to resist the pressure. So it may burst, you may get stroke, you may get coronary thrombosis, you may get all this angina, or you call heart attack. So smoking actually makes the arteries harden, okay, and it becomes less elastic. All right, okay, this a doctor told me, okay, because my father had a heart problem. He was a heavy smoker. So we brought him to the hospital and said, oh, please do not smoke anymore. And I was asking, why? What's wrong? Because it hardens your blood vessels. All right, okay. Do not drink alcoholic drinks. This one can also have a toll on your circulatory system. Okay, try to reduce alcoholic drinks and reduce stress. Right, stress is also known to increase your blood pressure. When you're always angry, when you always get angry, irritated, your blood pressure will rise. When the blood pressure rises, it will have higher pressure, and if your arteries are not strong enough, it is not tough enough, it will burst. Okay, and then you have a stroke. It happens in your brain, you get a stroke. It happens at your coronary artery, you're gonna get heart attack. All right, okay, next. Now, reduce and also maintain a healthy weight lah, right? Because if you are overweight, obese, and so on, it's going to complicate things. Your heart will be very difficult to pump your blood into your entire body that is so big size. So your heart will be working overtime. Okay, you're stressing your heart. Okay, look at the cardiovascular diseases. I want to explain one by one because some people get confused between a few terms. Okay, a few medical terms, we call it. Okay, atherosclerosis. Look at the underline, right? The difference here, the athero. The next one is arterial. Different spelling. Athero, arterial. They are slightly different in meaning. Do not use them interchangeably. Angina. Angina is where you have a tightness in your chest, right? You feel discomfort. Something is pulling, right? That is actually a sign that you might be having a heart attack. Okay. Then hypertension is high blood pressure. You can measure it using the sphygmomanometer to check your blood pressure. Make sure it's below 120 over 80. Okay, or that would be the ideal. We call it the blood pressure. And myocardial infarction. Okay, this sounds like a very fancy word. Yeah, it is. It is actually a very fancy word for what doctors use as heart attack. right? A normal people, layman people like us will say heart attack, but if a doctor will say MI, okay, MI stands for myocardial infarction. So you see what happens to the heart. Okay, it's beating, suddenly it went out of haywire, it didn't beat correctly, sometimes it can stop altogether. It is a heart attack. We call it a fibrillation. It went into fibrillation, right? The heart, the pumping of the heart is not regular. Something is wrong, right? And one more, stroke. Stroke is when you have a blood clot in the brain. Okay, the arteries we call it burst, and the blood flow out, right? And then into the brain tissues, all that, and it became a clot, yeah? And it affects your normal functioning of the body. Okay, so I'm going to explain one by one here. Hey, what is atherosclerosis? Okay, so you can see here, this is a cross section, okay, or longitudinal section of the blood vessel. This is the artery, right, or one of the arteries. So atherosclerosis basically means the formation and deposition. So it forms, and the deposit means it's stuck there, a plaque. Okay, plaque can be made, can be formed by, fats, cholesterol, okay, things that stuck onto the side of the wall here. So the plaque is formed from cholesterol, from lipid. It can be dead muscle tissues, coagulated platelets. Something wrong with the platelets are too sticky, so they got stuck over there, and then it made it become narrower. You see the blood vessel, the diameter became narrow because of the plaque formation. Okay, and this is going to clog the blood vessel. It will make the lumen narrow. Lumen is a little space there that allows the blood to pass through. All right, and it obstructs the blood flow. Obstruct means to slow down, or it blocks the blood flow. So it flows very slowly, or it can become high pressure. Okay, so the lumen has become narrow as a result. That is called atherosclerosis. Okay, next. Okay, you see the diagram here. The blood flow is constricted. I mean, the diameter becomes smaller, so it's very difficult to flow through. And as a result, you will have higher blood pressure, because the narrower the lumen, the higher the pressure will be. Okay. Now, what about arterial? Okay, arterial. So the spelling is slightly different. The sclerosis is the same. Now, arteriosclerosis occurs is usually one of the type of atherosclerosis. It's because of calcium is deposited on the plaque. So it becomes hardened. Just now we said plaque was formed, all right? It didn't say hardened. I didn't say the artery became hardened. But arteriosclerosis, the arteries have hardened, usually because of plaque formation, calcium formation. Calcium is there on the plaque. It makes the artery become hardened, and lose its elasticity. That means it's not elastic anymore. It is not able to resist pressure. So if the pressure is extremely great, if it's a very fine capillary, it will break, it will rupture. It ruptures and the blood flows out, then you have a blood clot. Okay? And the tissue will not get oxygen. So that's why if it happens at the heart, you have a, we call it a heart attack, where your muscles there, your cardiac muscles cannot get oxygen. It will not contract. When your heart doesn't contract, you have a myocardial infarction. You have a heart attack. Okay, so atherosclerosis is the early stage of arteriosclerosis. So the arterial is because of calcium deposition that causes it to be hardened, and it becomes less elastic. Okay, so the beginning is athero. Then it can turn into arterial because of the calcium deposition. All right, so here there's a slight difference between these two terms. All right, okay. So next, let's go on. Right, hypertension. I think this is simple. Hyper means over, too much. Tension is actually talking about the pressure. So you can see what causes hypertension is usually the diameter of the blood vessel. If the blood vessel becomes narrow, we call it restricted, okay, then you will have restricted blood flow. Okay, I'm sure you learn your Bernoulli's principle in physics, right? When your pressure, when the lumen, the diameter is bigger, the pressure will be lower. But if the diameter is smaller, you force the liquid to pass through a narrow opening, the pressure will increase. Okay, so you have higher blood pressure there. It can cause the fine arteries to rupture, especially the capillaries, which are very fine. Okay, the rupture is to break And if it happens in the brain, you get a stroke. We call it a stroke, right? In Cantonese, we call it 中风. In BM, we call it angin ahma, right? And if it happens in the coronary artery, the artery that carries blood to the cardiac muscles, you will get pain in your heart. That's called angina. Then your heart can stop pumping altogether. Okay, stroke can also be caused by blood clot. We learned this thrombus last week. Okay, thrombus is a blood clot. So the blood have somehow stuck together over there, and it blocked the flow of blood. So that can also cause a stroke. All right, next, angina. Okay, angina. Angina is the heart pain actually. All right. If the lumen of the coronary artery, that means this is the artery that supplies blood to the cardiac muscles that makes the heart pump, right, to the ventricle and so on. So if it becomes narrow, there will be insufficient oxygen supplied to the heart muscles, and that causes angina. Then that muscle over there, for example here, right, here, cannot pump. Here is that the tissue is already dead. So it doesn't pump. It doesn't pump, that means your blood is not flowing, right? Then you will have, first before it happens, you have the heart pain there. That is called severe chest pain. It's called angina. Okay, also caused by all these the blockage, right? Because blood cannot flow. Then all these are interrelated. When you have hypertension, right, you will have the atherosclerosis. All this can happen together. Okay, so chest pain, these are the symptoms. Chest pressure, squeezing sensation in the chest. Someone is giving you a signal, right? Quickly go to the hospital, right? Send someone, get someone to send not you lah. I mean, whoever that you know, right? You can suffering with all this chest pain and so on. It's actually your body giving you signs. Don't ignore it. Okay, until one day it won't give you any more sign. It will just heart attack and the person just pingsan there. All right. When it gives you the chest pain, that means something is happening. So quickly go and get it investigated. The pain can spread to your neck, can go back to the go to the jaw, the arms, the back, or the belly, because all these are the muscles, right? And because your heart supplies muscle oxygen to all these muscles, so they are deprived of oxygen, they may not be able to work. So you see all these symptoms happening. All right. So if the artery is completely clogged, that means no blood is passing through to that cardiac muscle. So those muscles cannot contract. You have a myocardial infarction. That means heart attack. It's just a fancy word for heart attack, right? Doctors will say MI. MI means myocardial infarction. Okay, so these are all the important terms that I've explained to you. Hopefully, I hope that you have learned what you should learn, all right, and help you to understand and also answer some questions in the exam. Hopefully, it's coming soon, right? The Form 4. For the exam, Form 5 is happening right now. Okay, so thank you very much, and I hope to see you in my next lesson. All right, I don't see any comments here. Maybe today's lesson is very straightforward, very too easy for you, and actually it's a good thing. All right, okay, I'll see you next week, hopefully. All right, okay, bye-bye, everyone. Bye-bye. See ya.